Let's take a look at this problem. We're going to solve the equation on the interval from 0 to 2 pi. So we got sine squared theta minus cosine squared theta is equal to 0. Now, one technique is to try to get everything in terms of the same trig function. And remember from our Pythagorean identities, we got sine squared plus cosine squared is equal to 1. Well, I can bring the sine squared over to the right side, and we get cosine squared is equal to 1 minus sine squared. So we can come over to our original problem here, and we'll replace cosine squared with 1 minus sine squared. Now notice I put parentheses around it because the minus that's out in front needs a flip sign of everything. So that becomes a negative 1, and then a negative negative becomes positive sine squared. Well, sine squared plus sine squared is 2 sine squared minus 1 equals 0. I want to get sine by itself, so I take the negative 1, move it over, it becomes a positive 1. Divide both sides by 2, and you get sine squared is equal to 1/2. Now the square root property. Square root property says if you got something squared, and we actually do have something squared if I rewrite it, because that notation there means sine to the second power. Square root property says if you got something squared equals something else, you drop your squared, and you put a plus or minus square root around the other side. Now we cannot have a fraction inside of a square root, so I'll split that up, put a square root around top, square root around the bottom, and square root of 1 is 1. And we can't have the square root down in the denominator, so we'll multiply top and bottom by the square root of 2. And we end up with sine theta is equal to plus or minus square root of 2 over 2. We got on our unit circle, we got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Pi over 4 is square root of 2 over 2, square root of 2 over 2. 3 pi over 4 is negative square root of 2 over 2 and square root of 2 over 2. 5 pi over 4 is negative square root of 2 over 2 and negative square root of 2 over 2. 7 pi over 4 is square root of 2 over 2 and negative square root of 2 over 2. Well, we're looking for a sign, which is our y part on our unit circle, where it's equal to either a plus or minus square root of 2 over 2. Here's a positive square root of 2 over 2, here's a positive square root of 2 over 2, here's a negative square root of 2 over 2, and here's a negative square root of 2 over 2. So it appears like our answers are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. But we'd want to check these to see if they work. Now, no matter what, when I square any of these, square root of 2 over 2 or negative square root of 2 over 2 is going to give us the same value. So when we subtract these, since these are both basically the same values once you square them, then it'll always check. So all 4 of those will check if we were to go through and do that.